Sometimes it is necessary to know the exact concentration of an acid or a base in a solution. Titration is a procedure that uses a base or an acid of known volume and molarity to react with the known volume of acid or base to form the unknown molarity. Confusing. Okay, so here, for example, let's say you are doing an acid-base reaction, acid-base reaction, and what happens? H plus combines with OH minus to form water. That's what is happening. So let's say here you are given the volume of sodium hydroxide, volume, and sodium hydroxide is a base, HCl is an acid. So let's say the volume of the base is given to you, and you are also given the molarity, the concentration of base. And what do you have to find out? The concentration of acid. Now here, when you are reacting HCl and NaOH, by adding base, we are neutralizing the acid. And when all the acid will get neutralized, you will see a change in the color of the solution. That means in your final solution, your moles of acid are equal to moles of base. Means all H plus is getting neutralized by OH minus. Now so in the final solution, your moles of acid, moles are denoted by letter A. Moles of acid are equal to moles of B. And moles is molarity times volume. So moles of acid is molarity of acid times volume of acid. And moles of base is molarity of base times volume of base. So let's say in this given reaction, if molarity of base is given, volume of base is given, and then you are adding this base to the acid to neutralize the acid, and if you know the volume of the acid too, then can we find out Ma? Yes. So here, for example, we use a burette to do this reaction. So here's a burette, and in this burette we have sodium hydroxide. And let's say we have the concentration of this base is 0.100 molar NaOH. And we have an acid here, and let's say we took 25 ml of acid. And what we do, we add an indicator. And what does that indicator does? That when all the acid gets neutralized, then it changes, the solution changes in color. So let's say we are adding 22.5 milliliter of sodium hydroxide from this burette, and this neutralizes all the acid. Then what is the molarity of this acid? So going back to this formula here, what is the molarity of acid? That we have to find out. What is the volume of acid? We took 25 ml of acid in the beaker. What is the molarity of base? That was given 0.100. And how much sodium hydroxide you added to neutralize this acid? 22.5 milliliters. So can we calculate molarity of acid? Yes, by dividing it with 25 on both the sides. So the molarity of the acid will be 0.0900 molar. Now the next concept is a buffer. A buffer is a solution whose pH changes very little when acid or base is added. And how do we make buffers? By mixing equal amounts of an acid or a base. So now when you're mixing it, we make the buffer from weak acids and weak bases. For example, this is a weak acid. When you dissolve it in water, it forms O minus plus H3O plus here. So now here, if we look at this solution, we have a weak acid and its conjugate base. So, and if they are in equal amount, approximate equal or equal amount, then we call it as a buffer. Now, what's the significance of this? What's the use of this? So here in this one, let's say if you add a small amount of acid, so we have all this in the beaker. When you add a small amount of acid, then that acid reacts with the basic part of the buffer and forms the acid. Or when you add the base into this solution, that base reacts with the acid part of the buffer to form the base. So that's why pH of the solution after adding acid or base does not change much. So here, example, let's take this acetic acid buffer example A. We are taking acetic acid of this molarity and mixing it with the equal amount of sodium acetate, which is the conjugate base of this acid. So we are mixing weak acid and its conjugate base, and when we mixed it and we check the pH is 4.74. Now in this mixture, if I'm adding HCl, and these many moles of HCl, then the pH just changes from 4.74 to 4.70, just a 0.04 change, which is not much. Or if I add, instead of HCl, if I'm adding a base, then the pH changes from 4.74 to 4.77. So this is what buffers do. It resists the change in pH change in pH when acid or base is added.
Made with Doodlecast Pro.